In this video, we are going to learn about exponential functions. This is our first topic for Chapter 11. An exponential function is in the form of y equals a times b raised to the power of x, where a gives us the coefficient, and that can be either positive, which tells us that the curve of the graph is above the x-axis. If it is negative, then it tells us that the curve is below the x-axis. B is the base of the exponential function. And we'll get more into the base when we start talking about logarithms. There are a few things that we need to know about the base. It cannot be a negative number. And it cannot be negative because the domain of exponential functions has everything. It cannot be 0 because if 0 was raised to the power of x, no matter what, we would get the line y equals 0. It can also not equal 1 because we would end up getting 1 raised to the power of anything, and 1 raised to any power gives you y equals 1, which is just a horizontal line. There are a few bases that we know. In math, the number system that we've been using with is the common base, which is 10. Today, you're going to be introduced to something called e, which is the natural base. E is just like pi, but we'll come back to that in a second. X is the exponent of the function. The exponent is always a variable that has no restrictions. So it is a variable with no restrictions. And this is because exponential functions domain is negative infinity to positive infinity. Now going back, again, the base can't be negative because the range of exponential functions does not cover negative numbers. Now let's talk about evaluating exponential functions. Exponential functions are just like any other function. We evaluate given some value. So we're given the function f of x equals 1/2 raised to the power of x. And we want to calculate what f of negative 1/2 is. So we're going to take 1/2, we'll raise it to the negative 1/2 power. Anytime we raise to the negative, we should reciprocal anything that's being raised to the power. So 2 over 1 raised to the positive 1/2. Now remember, 1/2 means that I'm taking the square root. So I have the square root of 2 over the square root of 1, or simply the square root of 2. Now here's where that number e comes in. So if I have the function g of x equals e raised to the second power, and I'm evaluating negative 2, I treat it just like any other function. So I take e, and I'm going to raise it to the negative second power. Again, if it's negative, I'm going to take the reciprocal and raise it to the second power, which gives me 1 over e squared. Now, since some of your tests and quizzes in this chapter have calculator and non-calculator parts, I'm going to leave this as 1 over e squared, because that is how I would leave it on a no calculator portion. So here, let's talk about e for a second. E is an irrational constant that is similar to pi, and it's approximately 2.718 and keeps going on, just like pi does. Now let's do some examples without the calculator, and then we'll talk about doing an example with the calculator. So f of x equals negative 3x, or negative 3 raised to the power of x. It is careful to note here that that negative does not belong to the 3. This is really the opposite of whatever 3 raised to the x power is. So if I take this, I'm going to do negative 3 raised to the power of 2. So I have the opposite of 9, which is negative 9. Now with your calculator, first let's put it in the form. So I'm evaluating at 2.3, so 10 raised to the 2.3. So if you take out your calculator, if I'm raising 10 to the 2.3, I want to type in 10, raise it to the power of 2.3, and evaluate it. I get approximately 1.99. I get 199.53.